This is part 10 of 8086 instruction set. We will deal with arithmetic instructions. We will first see negate instruction. So it makes the given operand negative by converting it into its 2's complement representation. So the given operand is actually converted by subtracting the given operand from 0. So it is equivalent to subtracting the given operand from 0 and we are left with the result. Okay, so this is the format of negate instruction. So the operand that we are specifying will be the destination. It means that the operand will be taken, converted to its 2's complement representation and will be kept back from the place where it was offered from. Okay, so the destination or the operand can only be a general purpose register or a memory location. So these are some examples of negate instruction. We have 5 in AL first, then we are negating AL. So what it means is that 5 will be converted to its 2's complement representation to be fitting in 8-bit space. Okay, so 5 will be converted to -5. It is represented as FB. Okay, now we are again negating the current value in AL. So current value in AL is -5. So it is negated so that we will get +5 back. Okay. Next we will see CBW, that is convert byte to word. So it actually sign extends a given byte operand to its word format. Okay, so the given implicit operand is AL itself. So the signed byte in AL is sign extended to a word to fit in AX. Okay, so as AL is implicit, CBW is issued as such without any operands. So we will see how this works. So suppose we are storing a negative number in AL, right? So the highest bit of AL will be the sign bit, it will be 1. And as we are issuing CBW, what happens is AH, right, it will be filled with all ones because the highest bit or the sign bit of AL was 1. Okay, so together AHAL will represent a negative number. Suppose that the highest bit of AL is 0, or it means that a positive number or a positive byte was stored in AL. Now what happens is when you issue CBW instruction, AH will be filled with all zeros. So AH-AL combination will now represent a positive number. So let's see an example. Suppose we are clearing all the bits of AX with zeros, right? Now we are moving -5 to AL. Okay, so we have a negative number in AL. So if you see here, right, the highest bit of AL will be 1, indicating that a negative number is stored there. Now we are issuing the CBW instruction. So what happens is this sign bit, right, it will be extended onto AH, right, or copied to AH. So what happens is the contents of AX will be like this finally, right? AH will be filled with all ones, right? These two F's indicate that. Then you will have your -5 as such in AL. So entirely this AX represents -5. Let's see CWD, that is convert a word to double word. Again sign extension takes place here, right? The sign of word in X is extended on to DX. Okay, because we don't have double word registers in 8086, right? So double word or values are represented by combination of registers. So if you have a word value in X, the double word combination is indicated using DXX. Okay, so AX is the implicit operand, right? So CWD is issued without any operands. So this is the working of CWD. Okay, suppose the highest bit of AX is 1, indicating a negative number is stored in X. If you issue CWD, what happens is all the bits of DX will be filled with 1. Okay, so that's what you are seeing here. All the bits of DX will be filled with 1. So DX AX combination will represent a negative number or a negative double word. Okay, suppose that the word stored in AX is positive or the sign bit of AX is 0. So what happens is extending that sign onto DX will give us all the bits in DX to be 0. So DX AX combination will now represent a positive number. So let's see an example. DX is initially cleared to 0, AX is cleared to 0, then AX is moved with a value -5. So if you see DX AX combination now, right, it will be like this, right? AX will be having the -5, DX will be having all 0. If you issue CWD, what happens is As you can see here, the sign bit of AX is negative, right, or 1. So that 1 will be extended on to DX. So what happens is DX will be filled with all F's, right, indicating all ones. Then AX will be as it is. So DX AX will indicate -5.